All right, thank you everyone for being here today. Like Matt said, we're going to be talking about SharePoint architecture. My name is Francisco. This is my colleague Rob. We are product managers for SharePoint and OneDrive for Business. Today we're going to be talking to you about SharePoint architecture. Look behind the scenes. So it's a little bit of be more of an involved tech discussion than some of the previous ones, but I promise you it should be fun. Hopefully not too dull. So we're going to start with architecture overview, then we'll talk about how we handle disaster recovery, and then we will talk about how we run at scale. So it's kind of the three main things we'll be doing today. All right, let's do a little bit of walking through memory lane. So back in 2011, we took our on-prem SharePoint bits and we launched them into the cloud. We didn't do a lot of changes. All we did is effectively had a wrapper around it. Pretty basic stuff. When it comes to running a service, there is a lot of human error involved. So we focused on automating as much as we could to remove that human element. In 2016, we had OneDrive for Business connect to SharePoint. This really grew in terms of our file growth. So reliability and scale became our top priority there. 2019 was the first time we started to talk about cloud-first investments. Prior to that, all these steps beforehand, we ran the service as our own bare metal. So there was no Azure integration at all. Roughly around the 2019 timeframes when we first started to use Azure Storage, and then eventually Azure SQL. After this, we started to deeply integrate across the M365 ecosystem. So we really embraced us being the file and collaboration platform. So multiple products started to run on top of SharePoint, and that really helped us really take advantage of all the investments we had made in the past. And then as Jeff mentioned earlier today, this leads us up to where we are now, the age of Copilot. All the work we've done before in terms of the investments we've made with Azure, as well as the automation of the systems, et cetera, this really has helped us to take this next step. All right, global footprint. We are in 40 plus Azure regions across 20 different geos in the world. And we are constantly evolving, growing into new Azure regions. The reason this is important is because for the rest of the talk, we're going to talk about things in a very singular manner, but everything we talk about is going to be replicated across the world, right? So it's not just a single data center, it's across the entire world. All right, let's dig into a little bit of the details here. So this is what our the OG architecture looked like. Lots of boxes. You can think of all these boxes as different points of failures, different roles, etc. Right? Like I said, this wasn't scalable when we first launched. It took us a while to really understand how do we move from the on-prem world over to cloud. So our first big evolution, our first like V2 of it, looks like this, right? Fewer boxes, and we started to define roles very specifically, right? You can see here bot, USR, a caching layer. Started to talk about SQL. This is our first integration to Azure Storage. We hadn't done SQL yet, but this is when we first really started to make those cloud-first investments. Now, what does a current architecture look like? If we give this talk in another year or two, this diagram here will be outdated, right? This is literally kind of point in time. So we like to think of the traffic that comes into SharePoint in three different ways, right? We have browser traffic, we have app traffic, and then we have traffic from third-party services. This all gets routed to our Microsoft front door. It's effectively just our global routing layer. This next big box here represents the SharePoint online service. This is what Rob and I own as a team. This first area here, kind of similar to what you saw before, bot, USR, cache, it's compute layer. What's different here is we have a bunch of microservices. These are a bunch of stateless services that are very bespoke. They do things like file processing, notification, et cetera. So we expect this area to grow. Next two areas are really where the majority of our Azure investment is. It's in SQL for our databases and storage for our blob content. Internally, we're the largest consumer of Azure. So we are deeply integrated with the Azure team. We spend quite a bit of resources with these individual engineering teams to optimize their layer so we can take advantage of it and in turn give you folks better experiences. Below this, we have the additional M365 services like auditing, compliance, admin, search, etc. And then finally, we have a managed service layer that we use to run our service. So I was mentioning how we embrace the file and collaboration platform. I'm showing this slide in particular because more and more we've really become to embrace that moniker, the file and collab platform. All of the productivity apps run on top of us, so Excel, PowerPoint, Loop, etc. All of the custom LOB applications you may have written, right, also run on top. As well as any of the third-party services like AV, CASB, etc. Why is this important? All your files, all your productivity are running on top of SharePoint in some form or another. That means you have trusted us with those files, you've trusted your productivity with us. And that's really, really important to us. So we spend a lot of time figuring out how do we continue to scale with new scenarios coming on, with increased user intensity, and keep it as seamless as possible. So this is what we're going to start talking about next. I'm going to hand it over to Rob.
Thank you, Francisco. So, disaster recovery. Francisco showed me this image yesterday, and I thought, wow, okay, yeah, that tells the story right there. So, disaster recovery, we're not talking necessarily about high availability. We're not talking about a situation where you have a hard disk failure or an independent component going down. We're talking about large disaster recovery, something that we either need to act on preemptively, we see it coming, or something that just hits us, and we need to be able to handle that and think in terms of hurricanes, earthquakes, these types of disasters. And similar to what Francisco's been doing, he took you through some historical view on how we've evolved things. This is an early version of our disaster recovery configuration. This is an active-passive model. What we have here is essentially we have identical compute, metadata, and storage infrastructure, regionally distributed but identical, running at the same time. And if we take an example of a file coming into SharePoint and kind of run through how this would work in this early model, you've got your traffic routed to your active data center. That data is written into SQL, synchronously copied in 3 copies. In parallel, we have blobs being written to Azure storage, and then we have another Azure storage blob being written into the passive Azure storage data center. All of this happens very quickly. This happens before you get your HTTP 200. This is the immediate result of having your file downloaded. We then replicate data into the passive data center. The replicated data is then represented all 3 copies. So this is working fine. Then we have, let's say something happens. We have a data center, a disaster, something's going horribly wrong. So what happens? At this point, our traffic is routed to the passive server. The passive server becomes active. You have access to the replicated data. And you still have access, hopefully, to both copies of the blob in the original data center, but also in the now active, previously passive data center. So this worked. This was enough to establish a recovery story, but there were some downsides to this. One is that we can't use all of this hardware. Our passive hardware, our passive farm, is essentially unused during this period until something horrible happens. This is okay, however, you don't know what can happen, right? So you've had a passive system, you are in a high demand scenario, and suddenly you're bringing this passive system live. There's opportunity for problems, right? So that's not ideal. The other problem is we can't actually use this hardware It's completely unused while it's in this passive state waiting for a disaster to strike. So what we did, we took this model, we improved this model, moved it to an active-active scenario. So essentially now we have two simultaneous farms. Again, they are separated regionally so that we don't have the same disaster hitting both of them. And it's when we have any sort of disaster in one area, takes down one, we have the capability to take all of that traffic and put it on from the two data centers into one and keep things running, keep things operating, and hopefully you don't notice anything at all. That's the primary focus of the active-active. The one part that's a little bit hard for us here is that we can't actually utilize all of this hardware. Similar to the last, where we had a completely passive, unused data center. At this point, we can use them both. We know they're both working at all times. We don't have the problem of bringing up a completely passive system to active. However, we can only use about 50% of our. We can only utilize about 50% because at any one time, one system's going to have to take the load of the full 100% load. So we are at this point working on and evolving this further. So now what we're doing is taking this to a system where we can take the two-farm model and increase the number of farms that we can put into this configuration so that we can go beyond 2 to 3 or more farms that will support this configuration. But at this point, we can distribute the failover data to more farms and more data centers. But we also have the ability to utilize more of our cores with the same hardware. So we have the same hardware footprint, but we can utilize more cores within that. And we, generally speaking, get a better utilization from the entire hardware footprint. All right. So this is the primary thing here. I think we get like a component level failure, and we have the ability to handle component level failures, but also to reduce the user impact when these kind of things happen. When we do an auto failover, we need to act very quickly. So we run a 4.9 system. So if we have anything more than, we can't have anything more than like 4 minutes and 30 seconds of downtime in a month. Given this amount of, small amount of downtime, humans can't interact with the system to handle failure. We have to fully automate everything, as well as fully automating to ensure that any failover that occurs as we move traffic from the failed data centers to one or more data centers that are up and running. We don't want any user any users noticing that this has occurred, but we also have to be able to fail that or do a fail back, right? So once the system is fully repaired and the system's running again, we need to be able to put those systems back in place, again, without the users having any sense that something has happened, loss of use in the system, any friction in the system. So that's a key of our auto failover system. If we talk about running at scale for OneDrive and SharePoint, if you saw Jeff's presentation today, you'll recognize this slide. We basically have 7 million peak requests per second that we're handling. We have 6.5 million cores, and we're storing about 11 exabytes of data. So what does that actually mean in terms of a lot of customers, a lot of tenants running? Well, we can't open up the numbers for all of our customers, all of our tenants, but we can look at our own. We can look at Microsoft IT. If we look at Microsoft IT, we can give you some sense of how that scale actually plays out over time and what we do to manage that. So in 2014, we had about 60 terabytes of data, and 20 terabytes of that was migrated into the system, and then the other 40 was essentially organic data that we started building up in the system. By 2016, we had a 10-time explosion of data here. We have OneDrive for Business coming on. We have files coming aboard, a number of files. And again, it's a massive amount of growth in those 2 years. By 2018, we're slowing down in terms of growth. So we see about 2.3 petabytes of data. And moving forward into 2020, we're 6.7 petabytes of data. And this is about the point where, this is a 3 times growth. And this is a good kind of window into what happens as user intensity changes, right? So we have, everyone moving into a work from home or a different type of work scenario. And you can see the impact in our own storage. By 2022, we're at 12.6 petabytes. At this point, within MSIT, 80% of our data is OneDrive for Business data. So this is, again, indicating OneDrive for Business, a big holder of data. And if we look at things as far as just 1 month back, 2024, we have 23 petabytes of data. Again, just shy of doubling in 2 years. So a lot of growth. These are really big numbers for a tenant. If you are a customer, you have a tenant, this may look like a lot of data, but Microsoft is not the biggest customer of M365. We are a customer, obviously, but we are not the biggest. It does show you, though, how Microsoft grows, how tenants grow, and how the system has to scale. So if you think about how Microsoft M365, SharePoint, OneDrive need to manage that customer growth, you've got to think about, or understanding your growth is critical for us. So we have to grow as you grow, and we've had trouble in the past figuring out how this growth will take place. So figuring out what regions will grow, figuring out what tenants will grow, figuring out, will sites grow. And so what we've done is we put a number of systems in place to help us do this. The first system we put in place is dedicated forecasting. We're taking historical data from SharePoint, storage, SQL, and building complex multi-year forecasting models, basically, to help us understand how this growth will play out over years. We started to look at really large tenants, take a look at how their growth patterns are playing out, and then figuring out how the overall system will grow. So looking at larger tenants. Then we started more recently looking at file level activities. So you might think of Teams recordings, for example. So we have a different type of usage, and it's telling us how we can expect this type of technological change will impact the system. Not necessarily just in capacity, but also if you think about what type of technological investments we need to make. So for example, video compression, these kind of things. So as we watch this file activity, we're again figuring out how we need to grow the system. Part of our ability to scale is really tied to our ability to handle database growth. The key thing here is really a process for managing database splits. We will typically see our databases grow very quickly, sometimes very, very large. We'll have to split these databases. We'll replicate the database. We'll drop redundant data. Then we'll take that and essentially do all of this without the user ever knowing that it's happened. So we'll separate databases a bit. And one of the main reasons we do this is for tenant move. As geos pop up all over the world, Francisco was showing a map with different green spots around the world where we have data centers. We have more and more coming online every month. Some of these are established in countries where people will need data residency and will need to move their tenant in, or will need to support multi-geo tenants in general, or we'll just need to balance capacity. So tenant move is an important piece of our tech, and the key part about that as well is that there's a seamless aspect to that, where we can move your tenant without the users actually feeling any interruption or friction from that tenant move. When we saw the type of user intensity change with work from home or essentially people working remotely, what we learned was we needed a system in place to help us deal with these capacity crunches. A new technology was invented within our team for capacity mitigation. It's capacity mitigation framework. And without this framework, what we were seeing was we would get a change in usage. The intensity of usage would go way up, and essentially we would start throttling traffic, and it would have a really unpredictable impact on the user experience. So you would see all of the applications tied to SharePoint Online start to behave in ways you wouldn't like. So essentially, the capacity mitigation framework tied in that our own signals around intensity, and then it mapped those in and integrated those into the first-party application, so that we can essentially have a predictable way for our applications to respond when we have different levels of capacity crunch. All of these things together kind of bring us to three key takeaways. We have within Microsoft 365 and SharePoint Online and OneDrive, a global, large-scale service. It's continually evolving the architecture to support a worldwide scope. Disaster recovery plans are in place with multiple live copies. We have the tech to reduce the user impact when these systems are engaged through auto failover and active-active systems. And in general, we grow when you grow. We learn from the growth patterns of all of our customers, and we apply those continually to improve how we manage our system. And with that, that's kind of our 20 minutes, and I thank you, Francisco, thanks you. If you want to talk about this more, we'll be over here in this general area, and you can ask us any questions you like.
Thank you, everyone.